you should be able to see this. So what I want to talk about today goes in part to what Mariana sort of put forward as the goal of these coffee talks about how can we think about integrating open science here, limited possibly to reproducibility. I'm not going to be able to talk about other aspects of it, but how to integrate it into the educational practices of our academic institutions. And one of the ways that I have tried it out this summer to integrate is not through our academic institutions as part of the educational program, but rather as an internship. But let me start by describing A, what this is about, and B, how that came to be. So in a paper, originally a webinar somewhat like this one, I had invited Richard Ball from Haverford, whom you might know from educational materials called the Tier Protocol about reproducibility, asked the rhetorical question, is it feasible to include reproducible research methods in undergraduate training? And his answer in the title of the paper was, yes, we can. I'm going to argue not just that we can, but actually that we should. It's not enough to simply say that this is feasible, but we actually should. But we should because we can. Why do I know that this is actually something that's eminently feasible? There's a lot of opportunity to do this kind of stuff. As of about right now, the replication lab that I use to sort of do these kinds of analyses has worked on 2,500 distinct manuscripts prior to their publication. And we've checked them for both their computational reproducibility and more generally their transparency about the description of how people can get access to the data and the materials and other things. We've been doing this with undergraduates. So since we started this before the actual AEA work started, we did some additional post-publication stuff that gave us the confidence that we could actually do this with undergraduates. I've trained more than 200 undergraduates who are the key drivers of what's going on here. So they do the assessment, they provide a lot part of it. But none of that is in the classroom. So this is the LDI Replication Lab. It's not part of a regular, at least at Cornell, curriculum. And the training that I give my students in order to be productive participants in that lab is necessary because I can't just sort of drop them in, they know how to do it. They have to learn a certain number of things. But these are all students, typically in their third year of an American bachelor's program. And they're eminently able to do this kind of work. I'll get into a moment how we generalize this. So just for reference, and I can actually share these slides after the presentation, what is a replication package for those who are not familiar with it? It's a package that that is compliant with the data and code availability policy that has been in effect more or less in its current state since 2019. We revised it in a year ago to align with the data and code availability standard, which is a common standard that as data editors of various journals, we came around and coordinated on a sort of standard policy. And you can find this as version 1 of that data and code availability standard. So this is the policy. The key elements of it is that you have to provide all of the code that you use to create the results that are in your paper, and you have to describe how others can access the data. You should also describe how you access the data, which includes scenarios where the data might be restricted access or limited availability or other things like that. So you must describe how you access the data in the first place. Replication packages can be browsed. That's part of what we've put together, is that they should be easily accessible. Here's a random one that I picked out that people can peruse if they want to. Once you start clicking into this, you will see a few of these things. That's not the topic of my talk today, and so I'm going to skip through sort of navigating through these kinds of things. What the replicator in the future we'll see in this public package is a README file and code and possibly data that describes the various things that need to be done in order to reproduce the analysis that's in the paper. Okay, so in this example, for instance, there's some data availability and provenance statements that point to the data being used. There's some CPI data from the World Bank. There's data from the Indian Human Development Survey. The README will go on to describe what does a replicator need to do in order to run this data code that does this kind of analysis. Okay, so how are the students involved with this? Well, they read these materials before they are published, analyze essentially, is the data provenance description that the authors have made understandable by somebody who is not a Nobel Prize winner or a Ph.D. economist or a faculty member that has years of experience, but by somebody who has some experience of exposure to the academic system of reading articles. Can they understand what is needed to acquire these data in the first place? Right? Their task is also to assess, is there enough information in the description to figure out, can we actually run the results there in the paper? Do we need to acquire some data because they're not included in the paper? Is this data maybe housed someplace where we can't easily access? Do we have all the software in order to do the kind of things? And if all of those ingredients come together, they will actually, not me or some of the graduate students, attempt a reproduction by following the instructions that are in the reading. As it turns out, inevitably, they're going to have to debug. They're going to have to communicate what it was that they actually debugged, and then they're going to have to write a report, which once it gets to me will be edited somewhat, and then sent to the authors in order to improve the package. So all of the elements that are on this list are subject to interpretation and improvement comments that these students come up with and that I might enhance. How are they trained? Well, they don't necessarily come with all of those skills. Each of those pieces requires some specific skills. And so we actually spend an entire day training them, with a few lectures on the principles of reproducible practices, of the purpose of open science and all those kind of things. That's a lot of stuff to squeeze into a day. As you can see from our August agenda, this sort of stretches out for about 8 or 9 hours of lectures and work. And then they follow up with 3 examples that they will do, depending on when we do this kind of training, is embedded over the course of the next 2 or 3 weeks while they do their regular classes. And then they're moved on to real cases where they gain even more experience doing these kinds of things. If you're interested in what these sort of training materials look like, we published this actually in the Journal of Statistics and Data Science Education a few years ago, and the training manual is linkable there. Okay, because clearly at this point of time, training 200 students, I'm going to have some sort of manual or training materials for do this. Okay, so what do they actually have to learn? Well, what they do have to learn is how to think about versioning. While all of the kinds of edits that they do remain confidential within our pre-publication environment, being able to reproduce our reproducibility checks when we talk with the authors in order to improve it is critical. They actually learn quite a bit about running code. They all come into the lab having been selected because they've run some code before, but they almost certainly will not have run a huge variety of the code that we kind of find in economics. So at the end of their stay with the lab, they will have probably run R, Stata, Python, Julia, MATLAB, maybe SAS, some of those things as well. And they have to be taught not just how to run the code, but how to run the code reproducibly so that we can come back to the authors and say, look, something didn't work, and here's why this doesn't work. Okay. They learn a lot of data acumen. That idea of where the data comes from, the data provenance, is actually not trivial. How should you interpret that? It says, well, in order to get this data, you have to apply. Well, as it turns out, you're applying to the Swedish data authorities, and you have to be in the European Union to access the data, and you might have to pay some fees. All that is critical information for our ability or any future replicator's ability to access such data. So how good is the data provenance description that the authors can provide? Right? If it's not exactly that case, but it's some other case where you might have to register on a particular website or maybe provide a short proposal, all those things about how to obtain the data is something that is entirely delegated to them. And They're guided along the path on how to do so, but they learn a lot about how to navigate our econ, social science, academic world of data repositories and data access methods and things like that. As it turns out, as probably most of you know, very little data in econ is actually obtained through APIs, which is something that when I talk to my computer science colleagues drives them crazy. But most of what we do in econ to obtain data is pretty manual and pretty delegatable to undergraduates, except they need to learn some of the things on how to do that. There is a lot of emphasis about knowing their rights and obligations when they acquire this data. What can they do with it? Apart from the fact that this is a pre-publication editorial level access to some of these data, they need to understand what it is that they're engaging to when they obtain the data, and whether or not that kind of restriction or obligation was actually mentioned by the authors when they describe their data provenance. Okay. And they need to report back to me and ultimately to the authors about their success or not and the reasons why they might not have gained access to the data and report on that. Okay. Communication is actually a skill that they have to learn quite a bit about. It's one thing to write a term paper. It's a very different thing to write back on debugging code, right? There always is some sort of debugging. We need to discern first internally whether or not the problem that the student ran into is of the student's making. Did they not understand something? Did they not do something right? That's a back and forth between them and me. But I'm not looking over their shoulders every time, so they're working relatively independently. And so we have to figure out how can they communicate to me what is going wrong and fix the problem in a certain way. Once they're done, whatever is not the student's problem, but rather the author's problem, needs to be communicated externally, and we tend to do so. That's my approach to this in a sort of constructive and objective way. Right? One of the first things I tell the students is there is no such thing as bad code. In our case, there is code that works and there's code that doesn't work. But that's not necessarily an obvious way to write objective communications that go to people who are far above their seniority. So that's something that they definitely learn about this. As it turns out, they also need to figure out how to organize their own work and their work within the lab and how to structure these reports, etc. We give them a lot of guidance about that, and it turns out that that seems to be quite useful as well. There are a few technical things I need to teach them. Obviously, I have some workflow management system, and how they need to respond to that is a very technical thing. As it turns out, sometimes I actually have to teach them how to use Windows computers. You'd be surprised how much of our current education system is actually online. And if you're just reading things or writing reports or etc., I regularly have some students who've never, ever in their life opened up a computer. They've just been on their iPads or something like that the entire time. So in some cases, this actually means that I need to teach them how to use specific computers. We happen to use an online Windows system as our primary system, but also some of the other tools that are there. Okay. So that's a lot of stuff. You would think that some of this they might have encountered in some of their classes before. As it turns out, not everybody has. Is this actually useful? Well, the students seem to think so. So over the years, I've sort of collected some feedback from some of these students. And just as a note, they don't all come from econ, not even as their second major. So some of them come from connected disciplines like biostats or sociology or political science. But in general, I'm obviously going to give you here some biased feedback from the students that actually thought that this was a great idea. Ideally, I'd actually have a nice little survey that I could run, but good luck with getting response rates after they've graduated. But they seem to find that many of these non-obvious things that we don't usually see as part of the academic curriculum are actually useful in the work that they do afterwards, right? How to provide that feedback turns out to be very useful in code reviews that people do even outside of academia. Apparently, this seems to prepare people well, even for a pre-doc or a PhD program. The feedback that they actually get from, for instance, seeing the author's responsiveness to the reports that they see and to see that this is actually something that they can solve and where they can provide a small piece of additional information to them is apparently very useful. So you might say that this is all, well, I've got students coming at Cornell, they're already a pretty selective crowd. And so I set out for last summer to actually expand this beyond Cornell. And so we have a random collection of partner institutions, not sure how these came about, but most of these, for those of you familiar with the North American education system, several of these are liberal arts colleges, so institutions that do not have a PhD program or even a master's program, that just have a bachelor's program. And then we have Notre Dame University for a variety of reasons, and University of Colorado at Boulder. We were talking with UNC Chapel Hill, but they ended up not participating this summer. And so in each of those cases, the local university provided a coordinator who selected students based on some rough criteria I gave them, but I did not select them. And in the end, they provided 9 students that worked for the replication lab as interns. We gave them the same kind of training that I just sketched out that I usually give my RA hires. We trained them in April. We had them then start several weeks later after their finals. And then the core participation was about 12 weeks. That's what was promised to them. They were partially supported by their own institutions. I paid them for about 20 hours of work a week. So it's sort of in between a full-time internship and a research stay. But they were funded by the journal for real work. They did real articles. They filed real reports. Those real reports went back to the authors. And in the end, they participated up to 16 weeks, depending on the person, because at the end of the internship, quite a few of them said, I still have a few weeks left in the summer before classes start. Can I continue working for the lab? They did about one case, an article a week. It's not just one article, because articles that are subject to revisions do come back, and they are usually reassigned to the same a replicator. So those small number of revisions count as a case. They usually did about one per week. So that's not an insignificant amount. They teamed up in the sense that we actually work independently, but discuss things in a group with some of the continuing Cornell students. A few of the students stayed over the summer as well. So there were these 9 interns, but there were also 4 or 5 students from Cornell who continued throughout the summer. What did they learn sort of from talking to them after the summer? They learned how to successfully debug. They also learned when to call in the extra help, as to when did they actually figure out when they did not know something. They definitely learned how to provide that structured internal reporting that I mentioned about earlier on, how to convey to others succinctly about what's not working for us to then be able to quickly hop on and discuss how to do this. And they learned how to write those reports. Almost all of them learned some additional new software that they'd never before used. And many of the things that we associated with the modern open science environment, like Git or Markdown, or also things that aren't necessarily obviously associated with that, namely automation and streamlining, are things that they found repeated use of over the summer as a way to reinforce any learning that they did as part of that. That's just because over those 12 or 16 cases, they used those same tools and in the end got actually quite comfortable with that. So those are students working on actual reproductions. How can we learn from this internship experience and think about where this kind of experience can be embedded within our educational environments? So for one, journals are generally organizationally distinct from universities. There are a few journals that are department level journals, but much of the production activity of that is still something that's not part of the regular academic activity, right? But most curricula actually don't include the methods and the tools necessary for fully reproducible work. Like I said, they're not active programming in this class, but they are conducting reproducible work because we need to show what we did. And so all of those methods and the mindset necessary to do that was part of something that they experienced as a part of their internship in the summer, and that they hadn't been conveyed throughout their curriculum, right? Where are reproducibility services like this run? Well, the typical research institution does not have such a reproducibility service. It's being run, in my case, at a university for articles that are part of a journal, but that just happens to be the case. So timing of the publication has something to do with this, but it doesn't have to be the key aspect to this, right? So the students provided feedback prior to the first publications. Authors actually appreciate that because it gives them what they call an element of closure. They have some feedback before we go public with this. There is a demand for some of this that seems to be emerging at the institution level. So the World Bank, I've got a link in there for you to explore, and some research institutes are providing their members or their staff with some pre-publication support at the institute level. This isn't even before the journal publication, it's actually even before submission to journals. On the other hand, the Institute for Replication is constructing quite a strong corpus of feedback that is all post-publication and happening there. How can we engage students more robustly within this environment where that level doesn't necessarily need to sync with the timing of publication? So one of the ways to think about this is that this nascent demand for these kinds of services at institution level opens up the possibility of integrating student work within an expanded curriculum and at the same time provide some of these services. What could that look like? And now I'm purely speculating, is a class that sort of takes as its output articles that are about to be submitted by faculty at the university and provides them with guided feedback through the same kind of process that we've sort of developed here, close to publication, but as a class project that happens, say, once or twice a year. Would this provide good feedback to the students? Making it into a class would probably reduce the amount of papers that can be processed, but would provide them with credit that they can put, for instance, on their CV about having done a class on reproducible science or something like that. Many of the tools, like I said, are not currently being provided in the curricula, so this is certainly an add-on that can happen there. So I've been talking about undergraduate education, but many of the tools that I just described are just as absent when those undergraduates graduate and then become graduate students somewhere down the road. So where would this fit within graduate education as well? So what my observation from graduate seminars is that some elements of that appear in graduate seminars through the various universities that have been going on there, but not nearly enough would be sort of my take on this. So actually just 2 hours before this started, I actually gave 2 sessions at the Humboldt University here. We've also been putting part of this into practice as a Cornell graduate level class. And many of those same elements that I talked about for the undergraduate education appear in that graduate curriculum. So what do I teach them in the ideal graduate curriculum? For instance, this is part of what we are doing at Cornell. One of them is something we call day one reproducibility. How do you start a project and maintain it as a reproducible environment throughout the process of developing an idea into a paper that will ultimately be published? And what that provides the students with is an early impact on transparency throughout the research process. So if you can reproduce what you actually did halfway through your research process, that actually has a serious impact on the future transparency of all these kinds of things. I tend to emphasize that we don't do in economics enough training on the command line. If we actually go and look at what is being done in some of the hard sciences, the very basic classes that I see out there, for instance, at software carpentry or things like that, in the biostatistics world or the computer science world is very much focused on the command line. If I do a typical survey of a group of graduate students, only very few will have actually used the command line. Explaining why that's important. Of course, not everything needs to be run from the command line, but understanding what it is and when to use it is, I think, an important tool for that. I tend to talk about writing articles that combine text and code, dynamic documents like R Markdown or Quarto or whatever the current flavor of the month is are very much in vogue. But there are also points or reasons why not to do this. What do you do when your code runs for 3 months? Then maybe that's not the way to do it. But how do you still combine documents in an efficient way with the outcome of running code on data? Which then ultimately leads to some aspect of high performance computing, which you need to understand and know about, and which ultimately combines some of that command line stuff, the setup of reproducibility from day one, into something where you shouldn't let your computer, your laptop in front of you, constrain how you think about a particular problem, right? I was working on a paper with some stats students, and one of the very first things that they said is, this takes like 2 hours on your laptops. And I said, that's not a good reason not to go forward with this project, because there are other tools available to think about this. There should also be a course on data ethics. We're obviously not going to talk about that here, but especially for open science, it's very important to think about what we can actually do in terms of data publication that goes along with the code publication. Like I said, in econ, we assume at this point that a data and code availability policy will always require the code, but what about the data? How can I make data ethically available when I'm subject to ethics boards, institutional review boards, the GDPR, all those kinds of things? How can we make that work and still be transparent and open about our methods? Which then naturally leads to reproducibility when data are confidential. So one of the things that often comes up is, well, I'm working, I don't know, the IAB FDZ, hello Dana, or the US FSRDC. Does that mean that I need to provide the same kind of replication package? The answer is an absolute yes. Simply because you can't publish the data doesn't mean that you can't be transparent about the methods you use to process that data, and many other people can actually access that data as well. And so ultimately, you're going to need to preserve some of this. You might be constrained by confidential data and creating an archive yourself. Maybe you're going to have to rely on your institution for that. Or if you're running a survey, what do I do with the survey data that I collected? When should I be archiving that and why? Okay. I then tend to talk about how do you actually verify reproducibility yourself, which is, as it turns out, not obvious, right? The obvious thing is, of course, it reproduces. It just ran on my computer, which is the worst answer you can give. And then we add on to that things about down the road, about writing grant proposals and referee reports. If you think back about the part I said earlier about my undergraduate students writing structured reports that provide feedback to people who are many years their academic seniors, referee reports and grant proposals aren't actually that different from that piece of the academic puzzle. Right? So these are the pieces in the graduate education. I talked about how to integrate this into undergraduate education. We definitely should be doing this far more often than we currently are. I'd love to hear about that. So where does this fit into the undergraduate education? If I sort of look at where I hire my undergraduates, the vast majority of them are what are called juniors, so the penultimate year of their undergraduate curriculum. I do hire throughout the entire life cycle. So I have some who are freshmen, so they just started their bachelor's, and some of them have been great. And I've hired people in their last year, and some of them might still not be ready for graduating by some aspect of that, but we get them there often. Where does this fit in graduate? In the North American system, definitely after coursework, so the third year that I was talking about earlier. But it should really be relatively early when you're starting to work on at least your own thesis. Maybe this is actually useful for better RAs as well. Okay. Training should include both pre-publication stuff. I think this is increasingly important as some of the post-publication stuff, including at the top journals, will have been subject to the kind of editing that we do. So it's important to see the things that can go wrong, to understand how to think about your own work and how you might prevent such things from going on. So you need some of the raw data, not the edited data that in principle is much cleaner these days because of the work that I and others are doing at journals. And possibly this might include some structured reporting. I'll point to the social science reproduction platform, to which I've had some input about how to actually report on things that one observes. Did you actually successfully reproduce? This is as much, if not more important, to convey to others than the hopefully rare event of this does not actually reproduce. So that's where some reporting bias needs to be addressed, and the social science reproduction platform was one attempt that we put together to do that kind of thing. And with that, I'll open up the floor to discussions.